In this video lesson, we are going to study the steps in electrophilic addition of halogen to alkenes. Our example today will be uh, electrophilic addition of bromine to an alkene such as ethene. Electrophilic addition of bromine to an alkene such as an ethene molecule. To make this clearer for learners, I will be giving you a step-by-step procedure on this addition. Now, we are using ethene as our molecule. All this is taking place at room temperature. So the halogen bromine, this is how the structure is written. For ethene, we will have ethene. We will have ethene. We will have ethene. Now, addition of a halogen. The halogen bromine as an example. Now, there is one thing you have to remember. The ethene molecule is not polar. The bromine molecule is not also polar. The ethene molecule here, what makes ethene molecule to be attacked, as we mentioned in our previous video, the presence of the pi electrons here. The presence of the pi electrons here will do what? Will cause a cloud of high electron density. There is a cloud of high electron density of the pi electrons around the carbon-carbon double bond. This cloud of high electron density of the pi electrons around this carbon-carbon double bond makes this ethene molecule open to attack by an electrophile. But you should know that as the bromine molecule approaches this cloud of high electron density, as the bromine molecule is approaching the ethene molecule, what happens? A cloud of the high electron density of the pi bond around the carbon-carbon double bond will induce a dipole. There will be an instantaneous dipole on this molecule. The cloud of high electron density surrounding what? Surrounding this carbon-carbon double bond will induce a dipole, and it is instantaneous. This is a temporal dipole. It induces a dipole into what? Into this bromine molecule. Now, when it induces a dipole into this bromine molecule, what happens? See what is happening there. A dipole is established. This is a cloud of high electron density of the pi electrons. As this molecule is approaching this cloud of high electron density, what happens? A dipole is induced here. Electrons are positive and electrons are negatively charged. So they will induce a what? They will induce a partial negative charge on this other end here, a partial positive charge on this end. Since electrons are negatively charged, the cloud of high electron density here will induce a dipole here. And the next dipole that is going to be here will be what? Will be the partial positive. In that case, bromine acquires a partial positive because the electrons are negative. And if this end of the bromine molecule acquires a partial positive charge, automatically the opposite end of bromine is going to acquire what? A partial negative charge. For that reason, the partial positive end of the bromine forms a bond with carbon, resulting in what? A carbocation. The partial positive end will form a bond. So let me represent it here with this. That is how it is represented. This is how it is represented. So we can now say induced dipole here. There's an induced dipole here. Induced dipole here. And the result is what? This is the result of this reaction. The result of this reaction is this one. There is a carbon there's hydrogen, there's hydrogen, there's hydrogen, there's hydrogen. What happens? Bromine is here. And what happens here? A carbocation is formed. This is an intermediate. So once more I said, bromine molecule is a non-polar molecule. Now around the carbon-carbon double bond there is a cloud of high electron density of the pi electrons. So as the bromine molecule approaches the ethene molecule, what happens? The cloud of high electron density of the pi electrons around the carbon-carbon double bond will induce a dipole here. They will induce a dipole on the bromine molecule, and this dipole is instantaneous. When a dipole is induced here, what happens? This end here acquires a partial positive. Meanwhile, this one here acquires what? It acquires a partial negative. Secondly, the pi electrons that are here will repel the bonding electrons here towards this other end of the bromine. And when that happens, it results in heterolytic fission. When it results in heterolytic fission, this bromine with no bonding electron will do what? Will benefit from this lone pair of electrons of the lone pair of pi electrons. It will accept the lone pair of the pi electrons to form what? To form a bond here with this carbon. Meanwhile, This bromine, the bromide that goes with the double electrons will do what? Will be formed here. This is it here. This is it here. This is an intermediate. Step number 2. What happens here? The carbocation that is from here, the carbocation that is from here, the carbocation that is from here is attacked rapidly by what? By this bromide ion. So the carbocation is attacked by the bromide ion. The carbocation is attacked by the bromide ion. And when it's attacked by the bromide ion, what happens? As the bromide ion is attacking the carbocation, it is at the same time donating this pair of electrons to this positively charged carbon, forming a bond, a new covalent bond established. And this is how the whole thing. So there is an attack by the bromide ion. On this carbocation. By doing like that, it donates electron to this. A new covalent bond is formed. And now what will be the resultant? The resultant in this case is this. The resultant in this case is carbon. You have this. In that case, we call this is the first carbon, this is the second carbon. We now say 1, 2 dibromoethane. 1, 2 dibromoethane is formed. Learners, let me go again. Addition of a halogen to what? To an alkene. This takes place the condition under room temperature. In the room temperature in the dark. See what happens? I told you that the ethene molecule is not polar. Bromine molecule is not polar. What happened? 1. The ethene molecule, because of the pi electrons here, the pi electron will create what? It will create a cloud of high electron density. It will create a cloud of high electron density around the carbon-carbon double bond. This high electron density, a cloud of high electron density. What happens as the bromine molecule approaches? As the bromine molecule is approaching this cloud of high electron density, what happens? A dipole is induced into the chlorine molecule since it is not polar. Electrons are negatively charged. So what happens? They will induce a dipole, and the dipole will what? The next end of the bromine will the next end of bromine will acquire but a partial negative. Since electrons are negative, the first end of this bromine will acquire but a partial positive. A partial positive. And when it acquires a partial positive charge, the other end of bromine will acquire a partial negative charge. So now, I represent them by using my curly arrows. The curly arrow does what? It indicates the movement of a pair of electrons. The pair of electron of the pi bond will do what? Will be donated to this bromine. The bromine having the partial positive N. So when a pair of electron is donated here, what happens? A bond is formed between carbon and the bromine. Now there was heterolytic fission. Since there was repulsion and most of the electrons within this bond were shifted towards the end of the bromine. Heterolytic fission resulted with this bromine going with a lone pair of electrons. So this is the bromine here. The bromine that went with a lone pair of electrons does what? It attacks the carbocation. So the carbocation that is formed is attacked rapidly by the bromide ion. And in the course of the bromide ion attacking the carbocation, it does what? It donates the pair of electrons that it took along to this carbon. And as carbon is accepting this pair of electrons, remember we said electrophiles are electron pair acceptors. So now when they accept this pair of electrons, a bond is established, a new covalent bond is formed between the carbon and the bromine. And the resultant product will be what? Will be 1,2-dibromoethane. This is the first step. And this is the second step. That's the first step there. And this is the second step. Examiners, they can give this, they might decide, as I earlier told you, they can give it in this way, and they ask you, or they might not give the bromine molecule and tell you, show using the curly arrow what is happening. You need to know that the curly arrow are moving from a pair of electron, a lone pair of electron to the electrophile. So it is the movement of the lone pair of electron. So you should know what is happening here. Heterolytic. They can say what type of fission is occurring here. Heterolytic fission. What is heterolytic fission? One of the atoms will go with what? Or one of the ions will go with what? With the bonding electrons, while the other one will have no electrons attached to it. Now, it leads to what? They may ask you, what is the intermediate form here? This is the carbocation is an intermediate form in this process. This is the intermediate, the carbocation. This is an intermediate. What happens within the intermediate, at this level of the formation of an intermediate? What happens is that the carbocation that is being formed is rapidly attacked by what? By the bromide ion, thereby donating the lone pair of electron that it took from this fission to the positively charged carbon. And when a lone pair of electron is donated here, what happens? A new bond is established. So this is how electrophilic addition of bromine takes place in alkene. Electrophilic addition of halogen, for example, bromine, takes place in alkene, especially in room temperature in the dark. So that is how it is. We can summarize this. You can still summarize this with an equation like this. This is the mechanism. We can summarize it. We can summarize it using this equation. We can use equation like this one. This to have this plus bromine we just want to show the equation, what is happening. You will see that what happens will be And we can now say this is ethene. This is ethene. This is bromine. This is bromine. This is bromine, which is has a brownish red color. Brownish red color. It has a brownish red color. And this is what? This is 1,2-dibromoethane. Dibromoethane. And which is what? It is colorless. So in that case, we will say only alkanes can decolorize bromine water. If an alkene is placed in a bromine water, what happens? The bromine water is brownish red. The color will turn colorless. It will decolorize it from the brownish red color to colorless. So that is even one of the tests that is used to distinguish alkane from alkene. With alkenes, the color will change from the brownish red to colorless. But with alkanes, nothing happens. Nothing will happen. Again, this is how you can summarize it here. This is a summary of it, of the mechanism that we have just explained. That is an ethene molecule. What happens? A cloud of electrons. There's a dipole induced here. What happens? Electrons are repelled. This pi electron repels the bonding electron towards the bromine. What happens? There is heterolytic fission. Bromine comes here with a lone pair of electrons. Bromine comes there with a lone pair of electrons. A bond is formed. The two pi electrons that are here will form a bond with the bromine, with the bromine, and this is the bond that is formed here. Now, a carbocation, which is an intermediate, is established. Now, the bromide ion with a lone pair of electrons now does what? It attacks this carbocation rapidly, doing what? Donating a pair of electrons here, and that pair of electrons helps to bind or helps to bond the carbon atom and the bromine, resulting in this. Examiners can give you, they may omit the intermediate stage, ask you to draw the intermediate stage. Examiners may write the intermediate and write the product and ask you to write the structure of ethene and bromine. They may write everything and put bromine here and tell you, show the curly arrows what is happening at this stage, what is happening at the stage between in the chlorine molecule, and what is happening in the stage with the carbocation. So the curly arrows are very, very important, learners, so that the marks are awarded to the curly arrows. So be very, very careful the direction of the movement of the curly arrows. Once more, as I said bromine in tetrachloromethane is used as a test to differentiate between alkanes and alkenes, as they both are colorless. You know that the brownish color of bromine is decolorized. The brownish color of bromine is decolorized when ethene is bubbled with bromine in tetrachloromethane, forming 1,2-dibromoethane. Again, there are other addition reaction of alkanes. Another example of the addition reaction of alkane is addition of hydrogen, hydrogenation. We have hydrogen as the reagent. The condition is we will have to heat in the presence of nickel catalyst at 150 degrees Celsius. And the product that is formed there is what? Is an alkane. From unsaturated compound to a saturated compound. So there's the addition. So In the hydrogenation of ethene, two hydrogen atoms are added across the double bond, and ethane molecule is formed. There is it here, 150 degrees Celsius heating. Nickel catalyst is very, very important. Another example of addition reaction is steam. Steam. The addition of steam, that is hydration. The reagent is steam. The condition is you have to heat the gaseous alkene at 330 degrees Celsius and at 60 degrees atmosphere, in the presence of phosphoric acid as a catalyst. Of course, the product is an alcohol that is usually produced. So addition, alcohol is, steam is hydrogen and OH. When it approaches here, there is what? It's the same mechanism, of what? The same mechanism here, a high density of pi electrons around here. What happened? A partial positive charge, a partial negative charge. Hydrogen will attach itself here, and there is splitting. Hydrogen attaches itself here to the two pi electrons. Then the lone pair of electrons that are here, the lone pair of electrons in this OH will do what? The lone pair of electrons that are here will do what? Will be donated to the intermediate that will be formed here to form what? To form this one. So if this bond is formed here, there will be a partial positive charge here. Just as I said the other time, I said the other time, there will be a bond. There will be a bond here with a hydrogen. A bond will form with the hydrogen. And what happens? An intermediate is formed here. This intermediate, the OH that left here, where is the OH? As a result of the splitting of this bond, the OH will do what? This will be the OH. The OH has a lone pair of electrons on what? On the oxygen. As we said, electrophiles are what? Electrophiles are electron pair acceptors. This one is now acting like an electrophile now too. So what happens? There will be an attack here. There will be an attack here by the OH. This attack here by the OH does what? As it is attacking this positively charged carbon, what happens? A lone pair of electron here is donated to this carbon. A new bond is formed. A new bond is now formed between carbon and hydrogen and oxygen. A new bond is now formed. This is how it is going. A new bond is formed. So the new bond is where? The new bond is here. This is where the new bond is. Between the lone pair of electrons on the oxygen and the carbon. And that is why you see this structure like that. That is how you see this structure like that. So that is the same mechanism. Watch our video on oxidation reaction of alkenes. Oxidation reaction of alkenes. Our next video will be oxidation reaction of alkenes. Thank you, learners. Thank you for watching. Please try to like, share, and what most importantly, you have to subscribe so that our next video comes directly to you. Thank you. Have a nice day.